Hello, and welcome to another week of Lifespan Development. So just like last week, I'm starting your lecture PowerPoint thing by answering a bunch of your questions that you left in the 321s last Friday. I've split them up again into class questions and content questions. I'm just going to keep that format throughout the semester because it's easy for me. So starting with class questions, I've noticed that you comment on everyone's discussion activities. Are we supposed to go back and respond to it? You are welcome to. I didn't comment on this week because you didn't need it as much. Some weeks I'll comment, some weeks I won't. You're not required to respond to my comments. It's really more me trying to get you to think. I'm providing you feedback. I'm not expecting you necessarily to respond. You're welcome to. I'm happy to have conversations about content with you, but it's mostly I want you to think about this, and I want you to think deeply, and that tends to be what I'm commenting on, is how to get you to think in a new way. Once you've graded the homework assignments, how do I go back to look at our answers? I tried looking back at the week 1 homework assignment, but it tells me to start a new submission. Yet, I can't figure out on Blackboard how to make it so that you can go back and check. If you have questions, I'm always happy to answer your questions about your homework assignments via email. Just, send me an email saying, hey, how come I did this? Or what did you think about this? Or I was wondering about. I'm happy. I love talking about class. So just feel free to email me or pop into office hours. Will all of these disorders appear on future exams? No. I don't think any of them are going to show up on exams. The exams are pretty much about theory, and then there's some physical development, but you will not need to know you won't need to know what the specific orders are. I'm not going to ask you to please define Klinefelter syndrome. I may ask you, please give me an example of a hereditary disorder. So you'll need to come up with one, but you won't need to know lists of them. You'll be fine. I want to know how to access your office hours. Do I need to make an appointment, or is there a Zoom link? There is a Zoom link, so every Monday and Wednesday from 2 to 3, I just sit here in my little corner waiting for students to show up. There's a Zoom link in the class information bit on Blackboard. So you can just put in that meeting number and it will bring you straight to me on Mondays and Wednesdays between 2 and 3. What is something you would recommend to increase our retention of the information? Think about it. Explore ideas in your brain. Ask questions of yourself. That's part of what the 321 are having you do, is I'm having you organize the information that you know you've learned, which helps your retention, but also by forcing you to ask questions, I'm making you think deeply about what you don't know, and that actually helps you retain the information you do know. So think about it and ask questions and explore the information and theorize on your own. So that's it for class questions, and now we're going to move on to content questions. Why isn't amniocentesis more common? Because it's very expensive, and in general it is unnecessary. So unless you have a predisposition to certain genetic conditions in your family, so like a lot of Ashkenazi Jews have a history of Tay-Sachs, or a genetic predisposition to Tay-Sachs in their family, so amniocentesis to diagnose that in utero would be important. If you're of advanced maternal age, which increases the chances of Down syndrome, amniocentesis can diagnose that. But in general, if you don't have a known genetic predisposition, it's an unnecessary medical test, and it does have a teeny tiny little modicum of risk to the baby. So it's not anything invasive. You're sticking a needle into a tiny little ball of cells. So it's going to be fine, but there is a risk to that. And so in general, you want to take as few risks as possible during pregnancy, and especially when it comes to invasive medical testing. What is the difference between a passive and active genetic environment gene environment correlation. So a gene environment correlation is the idea that genetic predispositions and environment work together to create certain things. So let's use the example of a girl named Peggy who has a trait that makes her a good singer, a genetic trait that makes her a good singer. Passive genetic gene environment correlation would mean that she's growing up in a family full of singers who are constantly, so her environment pushes her to develop this talent to become a better singer. In an active gene environment correlation situation, Peggy would seek out a better environment to help with this talent. So she would go to school and she would join choir, or she would join theater, that kind of thing. There's also an evocative gene environment correlation. This is where something Peggy does changes the environment. So she doesn't change her environment. That's what an active. So she doesn't, yeah. She, instead of finding a new environment, which is what an active gene environment correlation does, an evocative gene environment correlation changes the existing environment. So a good example of this would be Peggy's mother notices when she is 5 years old that she loves to sing. So she signs up Peggy for voice lessons, and she starts bringing Peggy to concerts, and she actively tries to expose Peggy to good singers and an environment. So something Peggy did changed the environment rather than Peggy just finding a new environment, which would be an active gene environment correlation rather than an evocative gene environment correlation where she changed the existing environment. I hope that makes sense. Can two genetic disorders be inherited at the same time? Yes. There's a link in the notes below to a YouTuber named Jessica Kellgren-Fozard. She inherited two genetic conditions, and you can hear her talking about that. Why is it so difficult to find answers to autism? Because it's probably, we know that it's not a single point mutation. So it's not one gene involved in autism, which makes it more difficult because there are so many alleles and genes in our genome that finding all of them and how they work together and how different things, that's why. There's thousands and thousands, I think there's millions of them, so that's why. I had a hard time coming up with a non-hereditary genetic disorder. So this came up a lot. There was also a lot of confusion in the homework about genetic disorders versus non-genetic disorders, and then within genetic disorders, hereditary versus non-hereditary. So a hereditary genetic disorder is a disorder that is due to a gene or a change in the DNA. So examples of this is sickle cell anemia, PKU, beta thalassemia, I can say that, those kinds of things. These are all originally mutations that become inherited. So many, many centuries ago, somebody had a mutation and then they passed it on to their kids and so on and so forth. And that's how that ended up in the environment or in our genomes. Then you can have chromosomal conditions. So this is a genetic condition, but it's not an inherited genetic condition. These are due to mistakes in mitosis or meiosis. Usually it's in meiosis because of the recombination and the extra stages, where you end up with extra chromosomes or not enough chromosomes or half a chromosome. So those are non-inherited genetic disorders. So that would include Klinefelter syndrome, Turner syndrome, Down syndrome, those where it's a chromosomal anomaly. In the video talking about what is defined as living or not, I was confused when he began talking about cells. He stated that cells are made up of non-living things. Is this accurate? Yes. Cells are made up of components that are not living. They are chemicals and molecules and proteins and various things, but none of the bits of a cell themselves are living. He stated that and that things such as mitochondria are not actually living. Did I understand that correctly? Yes, you did. So mitochondria used to be their own cells, which is why they have distinct DNA from the DNA that is in the nucleus of our cells. But they are no longer living. They gave up their life in order to preserve their DNA within our cells. So mitochondria are not living. What are the rules that you would make to imply something is alive or living? So my 4 rules are, and all 4 conditions have to apply simultaneously in order for the thing to qualify as alive. So they have to be able to die. They must be carbon based. So carbon based life forms, DNA, that kind of thing. They have to consume energy, and they must be capable of homeostasis of some kind. Those are my 4 rules. Is genetic counseling free / covered by insurance? When I was thinking about having anything to do with genetics, I typically think of the huge price tag. So, genetic testing is free when it is medically necessary, meaning you have a family history of Tay-Sachs, you are of advanced maternal age, so you may have Down syndrome, various things. If there's Huntington's in your family, usually genetic testing will become free. But if there is no medical reason for you to need genetic testing, then it's not going to be free. It's kind of like your insurance isn't going to cover an x-ray if there isn't a good bet you broke your leg. There needs to be a doctor saying, yes, this person needs genetic testing. Why can't genetic tests predict all diseases? Because not all diseases are genetic, and then even some diseases that are genetic, we don't know what genes cause them. So things like heart disease are probably caused by a bunch of different genes working together rather than just one. And also because heart disease, you're not going to inherit heart disease, you're going to inherit a predisposition for heart disease. Other things are infections. So typhoid fever, you get that from a specific type of Salmonella bacterium infecting your gut, and that's how you get typhoid fever. It's not a genetic thing, it's you ate shit thing. How early do you think we should start working on our final project? This week. If you read the email I sent you all this morning, you will know that already. You need to sign up for a meeting time for this week. You're going to meet with me. You're going to come up with 3 names. It'll be great. So yeah, this week is when you should start working on that. And sorry, I don't know why that ended up in content questions, not class questions, but here we are. And then the last question. Are talents truly passed down, or do they come from practice? Can anyone do anything, or are certain talents specific to people? So, talents are not necessarily passed down, but predispositions to talents are. So a good singing, you can become a great singer, but you need a predisposition of having a good musical ear. You need to have good voice. You need to have a good voice. You need to have a number of things that create a genetic predisposition to being a good singer. Likewise, if you want to be a track star, you probably need symmetrical. So they've actually found that symmetrical knees at birth predict good running or good cross-country running later on. So that is a genetic predisposition to good running. Your symmetrical knees that you got from your parents gave you a predisposition to being a good runner, but also you're going to need some other things to be this good runner that are genetic based. You're going to need good lung capacity. You're going to need an efficient aerobic system. You need to be able to process lactic acid efficiently, those kinds of things. So predispositions for talents are genetic, and then whether or not that talent is fostered and you actually use that skill, that is environment. So it's a nature and nurture together kind of thing. So that's all of the questions I'm answering this week. I will be back next week with more questions to answer. And in the meantime, enjoy the rest of your lecture.